coming to the basic architecture of the system, it depends upon the kind of embedded core we are using. Now, if it is a general purpose processor, it is basically based on sequential fetch, decode and execution of instructions. In case of a general purpose processor, the data path is general, but the control unit doesn't store the algorithm. The algorithm is programmed into the memory. So, so depending upon the type of processor, the instructions are fetched sequentially from the memory, and then they enter into the instruction register where they are decoded, and based on the instructions, data is being passed to the data path, and in course they are computed upon with the help of control signals being issued by the control unit, and the computations typically take place in the ALU, and the results are stored back in the registers. The control unit basically issues the control signals to regulate the flow of instructions and ensure the instructions are executed in a timely manner. They perform the controlling of the different operations involved in the execution of instructions, like the fetching of instructions, decoding of instructions, then perform the basic execute operations in the ALU, and then they also fetch operands to compute on and store the results in the back in the memory. So when we talk of choosing the particular embedded core, we have to answer the questions like what is the resolution of computation we need? Should we go for 8-bit, 16-bit or 32-bit processors? And because the larger the bit length we go for, there will be more power dissipation. On the other hand, the accuracy of computation will increase because we have now the resolution of computation is spanned over a larger number of bits, which means the error in computation will be less. One of the important aspects of choosing the processor is the clock frequency. The clock frequency must be sufficiently high to produce the results within a reasonable time frame, and it should be sufficiently low to ensure that not a lot of power is being dissipated. So it is again an optimization problem to solve. What should be the right clock frequency for the particular application being concerned? Typically, we for a certain clock frequency, we keep on increasing the throughput by going for pipelined architectures, where we ideally expect to have one instruction being executed per clock cycle in the steady state. To further boost up the speed of execution of instructions, improved architectures such as superscalar and VLIW architectures have come, where you have more than one instructions executed per clock cycle. In case of superscalar processor, you have a set of ALUs to support more than one instructions per clock cycle. In case of superscalar processors, instructions are fetched in batches and executed as many as possible through parallel data paths. On the other hand, in case of VLIW instructions, each instruction word is basically a compound word with multiple simple instructions within it. They are fetched in one go and decoded and executed parallelly. So these are the two approaches by which we can increase the speed of computation to more than one instructions per clock.